Welcome back to the Rollup. Today, I sat down with Avi Zerlo from Nil Foundation. Nil Foundation is focused on a concept called zkSharding, and they believe in this idea of horizontal scalability. Today, we discuss the primitives of horizontal versus vertical scalability, modular scalability versus monolithic scalability, and some of the core ideas which Avi believes is the future for scaling Ethereum. We're big fans of the ZK work that they're doing, and we had a really informational and technical conversation. Hope you guys enjoy. Real quick, here's a quick insight from some of our partners, and then we'll jump right in. Welcome back to the Rollup. Today, we're going to talk about some of the scaling solutions present today, and also some interesting mental models for the modular scaling space, as well as for EVM rollups. Today, we have Avi from Nil Foundation. Nil's working on some really cool ZK tech, as well as just general scaling technology. Avi, welcome to the show, man. Would love to learn a bit more about you, but first and foremost, welcome, bud.
Thanks, Andy. Appreciate you having me. Excited to be on the roll-up. Love you guys. You guys are doing some great work in the space.
Yeah, I appreciate you coming on the Twitter space the other day as well, and positing some horizontal versus vertical scaling mental models, which I think got the people going, which we'll definitely dive into. But why don't you tell us a bit about how you got into Nil and kind of why you're passionate about this, this role in the space?
Yeah. Oh, yeah, definitely. And hopefully we get the people going a little bit more today, get some provocative takes maybe. I'm Avi Zerla. I'm our Chief Product Officer at Nil Foundation. I joined last fall. Prior to that, I was at Delphi Digital, running and helping lead investments, part of the Delphi Ventures team, for just shy of 3 years. And that was an incredible experience, but a builder itch, and Nil Foundation was, an incredible setup for me as a sort of business-minded, product-oriented individual. Nil has been around for a long time, established in 2018, been at the cutting edge of ZK research and engineering and just technology broadly. And this year and last year, the focus of the company has been on developing Nil, new Ethereum L2. And that's where I've sort of come in and I'm helping lead a bunch of different things, build out a team, and we're really stoked about rolling some product releases out in the coming months.
Nice. And Avi, real quick, before we jump into the tech, more of a just like a life question. You
Yeah.
being part of like a venture capitalist firm, it's very much like speculative oriented, research oriented, consistently trying to stay ahead of the market, stay ahead of kind of like the broader crowd. Always open to new things, willing to kind of change your thesis. But then being a builder, you kind of almost have to do the same thing day in, day out, just keep knocking down the wood, just putting those nails in and just keep and staying very consistent, like not going to like the shiny objects and different things. And I'm just generally curious, like how this change in your life has kind of happened from a career perspective, and like what are some of the key differences that you have noticed, from like this more strictly investing, speculating to more of building and product focused environment.
Yeah, great question. I get asked this a bunch. You should ask my girlfriend. She'll probably say that I'm a lot more stressed and a lot less available. Um, But I mean, seriously, it is like a very different like space to be operating in. I think one of the clearest distinctions for me, especially in a lead product role, right at Nil Foundation, when you're trying to solve product problems, you're essentially thrown like hundreds of different small problems that you need to solve, and you need to make decisions that can have a multitude of outcomes, and there can typically be from every problem a number of decisions that you have to make, all to shape and craft this sort of amorphous like product vision that you have, right? And Steve Jobs has like a really good quote about this, where you're making thousands of decisions to kind of polish out this sphere that you have in your mind, which is totally different from investing, right? Investing, you're spending a ton of time consuming and synthesizing information. You have pretty long decision making cycles, right? So as long as the market's not like ridiculously hot, you can have a few weeks to really think and research and understand a company or a piece of technology, and then make a pretty binary decision about what it is that you want to do. So all in all, it's a very different experience. It's been incredibly fulfilling. I love it. I don't regret it at all. I love all of my investing friends and the investing lifestyle. It's great. And sometimes I scratch my head, why did I do this to myself? But I wake up every morning just amped to like be working on the products that we're working on with the team and the engineering talent that we have. So I'm super happy.
Yeah. Yeah, we kind of play both roles here as well and feel the tug, right? Like when we're in a speculative burst in the market, as well as over the last 6 months we've done a ton of angel stuff. And so it's very methodical and synthesizing your information and trying to make comparative valuations and estimates and run numbers. And then when you're building the products and working on the business, it's like, yeah, it's very much like putting out fires and then like constructing systems to not have to put out more fires in the future.
Mhm.
And it's like a consistent process of like systems. And yeah, it takes two different mindsets, but yeah, I was generally just curious about your path. Now moving towards more of like this roll-up conversation, I think
Mhm.
that let's just call it the fragmentation problem. Let's lay the land. We have a ton of roll-ups in space. We call it,
Mhm.
I think you guys and you called it state fragmentation. Effectively, we have all these different roll-ups existing in parallel with their own roll-up state. And we kind of have this state fragmentation problem where users have to still bridge, and there's some concerns around the roll-up centric roadmap really taking shape if we've got all these different execution environments within the Ethereum umbrella, but sometimes it doesn't really feel like it's all under the Ethereum umbrella.
Mhm.
So let's talk about your perspective on the state fragmentation problem for EVM rollups. And I know that you've just put out a piece about this. So yeah, would love to learn about your perspective.
Yeah, definitely. Happy to share a little bit more here. I think to start, there's an important note, which whenever you spin up a new chain, there is inherently state fragmentation, right? And because by definition, that new chain isn't necessarily sharing the same global state of the other chains within that quote unquote ecosystem. And this is just baked into the way that blockchains are designed. Is actually baked into the way that databases and distributed systems are designed. The issue that we see with state fragmentation and how it's playing out in the Ethereum ecosystem specifically is that we're seeing a proliferation of it, right? And that proliferation is effectively manifesting in the many different L2s and L3s that do not share some notion of a global state, right? And the notion of a global state here doesn't necessarily have to be that every rollup is executing and processing over the same state root. for example, which was, but that they at least can arbitrarily call one another. And so that you have this like unified notion, again, a unified notion of state. And what we've seen is a ton of roll-up companies, as I think everybody expected. This is, one of, if not the most important market and, product to be built within the Ethereum ecosystem, right, to scale blockchains. Yet we've gone kind of off the deep end in that we have now like hundreds of chains and applications are spinning up their own chains left and right. And we still have not yet solved for the ability for these chains to arbitrarily communicate with one another. And in our view is actually this problem isn't an interoperability problem. It's actually a scaling problem in that the more that you can actually scale the rollup itself, right, or the L2 itself, the less state fragmentation you induce on the ecosystem at large, right? And that what we're seeing is app chains are spinning up, or applications are spinning up app chains or app-specific rollups because current rollups aren't offering the product features that they're looking for, which is, speed, avoidance of the tragedy of the commons and congestion fee pricing, security even at times. And to us, that's indicative of not a desire for applications to say run all of their own infrastructure. It's more of just a function of the limitations of current rollups. And this is where we think we need to kind of revisit some of the mental models about, well, how do we actually scale blockchains, including not just the L1, but also how do we scale a rollup, right? What are the processes and frameworks that we can implement to handle more throughput at lower costs, or reliably lower costs?
Yeah, I think a lot of the pushback that we get from the Ethereum perspective is that the L1 is just not fast enough. It's not performant enough. So is our rollups not performant enough from your standard? Is that due to Ethereum L1 not being performant enough to allow for rollups to scale? Or is there a different reason why, it's from your perspective, it's not an interrupt problem, but rather a performance problem?
Mm-hmm. Yeah, I think scaling the L1 helps, right? And we see that with the blobs, right? And that you see immediately a reduction in your fees at the L2 layer because data availability costs are dropping. And so there's work to be done that effectively scales the L1 that then benefits the L2s, right? And blobs are actually a scaling solution for Ethereum towards zkSharding, right? And it's effectively a form of sharding, which is a very tried and true practice for horizontal scalability. Now, for the L2, at the L2 layer, right, one of the sort of low lifts for L2s is, say, the parallelization of a virtual machine. And this very directly increases the performance and capacity of an L2, right? Yet what we've seen is a lot of kind of naive implementations of the EVM, right, across layer twos and across rollups. We've also haven't seen sort of really good architectural models for at the layer two level that allows for horizontal scalability, right? In that horizontal scalability gives us the power to simply add new machines to the system of interest and access many machines, the power of many machines at once, while maintaining the ability for, say, applications to arbitrarily call each other. So the spirit here is like almost like a call to action for L2s to just simply running a naive implementation of the EVM isn't going to cut it anymore, right? We need to find new ways to offer a product experience for essentially application product builders to get the requirements that they need out of a blockchain.
Cool. So I think we're in agreement.
Mhm.
We've invested in a ton of alt VM or next gen VM rollups. Also
Mhm.
are in DA layers and kind of generally see this idea of this path. Uh, my other concern with this situation is we are pushing for more scalability, which I think is a noble cause. We need this to onboard new users,
Mhm.
developers, really just get this space to the next level. But like, at what rate do we sacrifice some of the censorship resistant properties of using EVM or Ethereum for DA, or just the tried and true methods versus kind of engaging in something like your zkSharding or horizontal scaling or other kind of for lack of a better term, like insertions to create a better system. How do you kind of balance this desire for UX and speed versus like censorship resistance and trying to build a super resilient system?
Hmm. Yeah. I mean, good question. And I think so. I think this is, kind of an opinionated question, right? Because there's this like balance, and I think you're right. Generally speaking, there is this balance between um, oftentimes scale and like how censorship resistant you are, right? Or like what are your decentralization guarantees? Um, and but I think there's also an important, very nuanced point here, which that is actually a constraint that is inherent to the single machine model of blockchain design. In that, in blockchain design historically, you have a single machine that is the bottleneck of processing and building blocks onto that blockchain. And this means that if you want to increase your scalability, you need to increase the requirements of that machine, or you increase the utilization, the hardware utilization that blockchain node is actually is able to access, right? And eventually, what this trends into is centralization, because you're increasing, you hit the limits of what the original hardware requirements are, and if you want more scale, well, you've got to boost your hardware requirements. And this is where horizontal scaling really shines, in that you you can simply add new machines to this blockchain, to the system of interest, and you're just distributing the workload across those machines, right, across those clusters, those shards. And those shards, you can run decentralized consensus algorithms over it, decentralized protocols. You can run in our case, we also run validity proofs, and you can get really nice decentralization and censorship resistant properties without having to make really significant trade-offs, or because you don't have to make significant trade-offs on the hardware end of things. Um, Now, when it comes to the, like, say, the role of Ethereum, right, the grandfather, the, like, hands down, like the OG censorship resistant, most operationally resilient blockchain in the world, that plays a critical role. And I think how every L2 should be thinking about their future, right? And how does it play even today? In that it needs to be the arbiter of truth. Like, Ethereum needs to have, say, a final stamp on what is going on for you to legitimately call yourself an L2. And there's ways to do that, right? You can have DA guarantees, and you can have, say, settlement guarantees. Guarantees that whatever your proof mechanism is that attests to what's going on your network can be verified on Ethereum. And the trade-offs between them are DA are the lion's share of costs. So if you want low fees, then you're probably going to need to find a different DA solution. I think we've seen a lot of L2s hesitant to offer this, right? Because there is this feeling of, well, DA makes everything, like it is the most important thing for end users. The reality is it's not. And instead you see, users and applications just moving to running like optimums or optimistic L3s and validiums anyway. And so I think the L2 landscape really needs to like take a hard look at, well, what is the product experience that we want to give to end users? Have really clear values about what are the trade-offs they're willing to make and what are the trade-offs they're not willing to make, and then go from there. And I feel like it's kind of been opposite, and we've kind of left the product experience side of things a little bit by the wayside.
Interesting. Yeah. So more vertical scaling with more machines brings us to higher cost of entry, higher barriers to entry, more centralization. Horizontal scaling, just expansion of machines in a sharding-esque environment allows for arguably more decentralization and more throughput. And doing all these things under Ethereum is like kind of like the ultimate end goal, and such that Ethereum as a settlement layer, and even potentially as a data availability layer, is going to continue and should continue for like this Web3 moral compass kind of conversation. And so I generally think that there's kind of this idea here that we're getting at with horizontal scaling and what's going on with these app chains, this kind of modular expansion that we've been talking about quite a bit, is that we're seeing a lot of these applications go onto their own app chains, and kind of go L2, L3. In your mind, is this vertical scaling, not necessarily when it comes to like hardware and zk, but is Ethereum scaling vertically, or is that a form of horizontal scaling in its own right? Kind of abstract, but
no. This is a great question. I mean, this is an awesome question, and I think you're kind of like, you're hitting the nail on the head. I mean, one, adding layers on top of like existing systems, like that is not a form of vertical scaling, right? Like vertical scaling, and this is a little confusing because you're stacking layers, right? You are going vertical in the architecture of the blockchain, but vertical scaling and vertical scaling is like a technical framework for scaling databases and distributed systems, and vertical scaling is like by definition the scaling framework that increases the computational power of a single machine, right? So in order, scaling is the ability to handle increasing or growing number of transactions, right? The only way that you can do that is if you increase your computational resources, right? The unit of power. And you can do that by increasing, say, the computational resource of a single machine, or you can do it by distributing the workload over many machines and adding new machines, right? Which is horizontal scaling. And so I think this is where, like, coming to the mental models discussion, like modular versus monolithic kind of gets a little iffy in its relationship with scalability. Because, for example, let's say I have 3 tasks, right? Now, in the world of machines and digital machines, we can run things in parallel, right? And so if I have 3 tasks, I can outsource those 3 tasks over, say, 3 CPU cores on a single machine, or I can outsource those 3 tasks to 3 different machines with a single CPU core. Now, the latter is a modular architecture. The former is a monolithic architecture. Now, neither of these are more scalable than the other, right? I still have 3 computational resources, 3 computational units to spend. If I add another machine to the modular scenario, I now have 4 computational units, yet I'm still just as modular. I'm still like a modular blockchain, right? Yet I'm now more scalable than the monolithic. But let's go back to the monolithic, and I add a CPU core. Now I have 4 CPU cores, right? And now my monolithic architecture is just as scalable as my modular, right? So and this is where I think the modular and monolithic it serves a great purpose in understanding kind of like flexibility and customization and the freedom, right, of what you can do with your modular stack. But it doesn't explicitly say things about how you fundamentally scale the system. And so there's this almost other axis that we kind of need to, I think, like reckon with, which is, well, then how do you actually scale each of those systems? Yeah. Does that
Yeah.
follow? Yeah.
Yeah. And
Okay. Cool.
so in this example where we have all like 3 or 4 cores in one machine, I think like you hit it on there. You hit on it at the end there. Like the core differentiator there may not be the difference in scale. However, if you're an application in this kind of monolithic 4-core system, you're at the mercy of the other cores. If you are an application in your own core or in your own computer system as a standalone, then you're more modular in the sense of your sovereignty. But again, it just comes down to these design choices, which I think are it's definitely a blurred line, but I think
Mm-hmm.
that you've helped clear it up for sure. Now, how about Cosmos versus Ethereum? So Cosmos has all these app chains. Is this horizontal scalability versus Ethereum rollups being vertical scalability, or is this not a good model?
Well, no. I think this is a actually totally valid question. And I think you're right, except for the last piece. I mean, Cosmos is, I think, in spirit, and so was Polkadot, for example, right? A manifestation of sharding, right? In that, like, you have these many chains, but they are able to arbitrarily communicate with one another through IDC, right? And so we have this notion of a global state, right? Because we can arbitrarily call one another. Now, the other piece that we didn't discuss when it comes to like a notion of global state that I also think is important to include is some form of like shared consensus, right? And in the world of Cosmos, the the ability to use interchain security, right, from the hub and reuse the security that is offered from that validator set, that's a very true form of sharding in my view. Now, Ethereum also has like a sharding roadmap, right? And bank sharding is going to be one of, if not the largest development for Ethereum in the coming years. And this is a form of horizontal scalability. And it will bring about significant scale. Now, the one piece where I just want to clarify is that the rollups are effectively scaling the consensus of Ethereum, right? In that now Ethereum's consensus is able to validate all of the activity and the blockchain that is of a rollup, given the appropriate DA and proof mechanisms. Now, this isn't strictly a form of vertical scaling, right? Because rollups typically implement kind of a naive EVM. And so we don't see the ability for a rollup to say, parallelize transaction execution. Rollups aren't a form of vertical scaling. And in fact, okay, I'm actually maybe going to retract what I had said before, and say something maybe a little bit more provocative, which is rollups aren't a form of scaling at all, period. And because it doesn't satisfy the requirements that we would want from scaling, which is the ability to arbitrarily call other addresses in this system of interest. And when we think about sort of Ethereum, right, we have Ethereum state, and Ethereum consensus, and now we spin up a rollup, right? This rollup has no idea what the state of Ethereum is, right? It is not interacting and cannot arbitrarily call Ethereum state. It is secured, right, by Ethereum consensus. So, and this is where I'm explicit about rollups scale the consensus of Ethereum, but they're not a scaling solution for Ethereum, right? And this is why we call it like a separate thing. This is why it's an L2, right? It's not an L1 scaling solution. Now, if you adopt this framework, the rollups now have the onus of then scaling themselves, right? In that they can share the same consensus guarantees from Ethereum. They get that out of the box. But then they need to be able to arbitrarily call one another. And what we've seen is you're not able to do that. We've also seen that rollups have been hesitant in altering the EVM, which is coming to the parallelization point, right? We can scale a rollup without adding new rollups, right? We can scale a rollup by simply parallelizing and increasing the hardware utilization that rollup can access. We can also, in the case of nil, increase the scalability of a single rollup system by introducing horizontal scalability through sharding directly into that L2, right? And in our view, we feel this is, in the long term, the most scalable path forward, in that you're always going to hit limitations if you want to vertically scale of a single machine. And if you ever care about decentralizing, you're always going to be inducing some sort of prohibitively expensive lower bound if you want to juice more scale. So you need to find a way to distribute workloads across many machines. And that's kind of the first principles starting point that we took in designing Nil.
Yeah, so talk us through a bit more about the design of zkSharding and how and why zk is involved, why that design choice was made, and what does a practical implementation potentially look like, leading to more unification of this general fragmentation problem that we spoke about in the beginning.
Good question. And I'm going to start with maybe an obvious point, and a little bit of an ironic one, which is we want to solve state fragmentation by building another L2, right? And it's like, oh, well, great. Like, technically speaking, that is just another, form of state fragmentation. The difference is we believe, and we actually are really large supporters of everybody else who's building more scalable L2, so you don't have that second order effect where an application wants to come build their app, but they are afraid that they're not going to be able to get the product requirements that they want out of your L2, so they spin up their own one, right? So what is nil? Right, nil is a sharded rollup, a sharded L2 that pretty much brings a lot of the work and ideas from Ethereum's original sharding vision to a layer 2. And what that does is it allows us to essentially access the power of thousands of machines from a single unified network. So we get thousands of rollups, right, that a developer can essentially access from one single interface, an integrated developer experience. We also are decentralized, right? We're designed to be decentralized. So it's not only that you're getting access to thousands of, say, rollups, but you're getting access to thousands of decentralized rollups. And in our case, because we are a true sharding protocol, those are called shards. And inside of the protocol, there's baked in communication between each of those shards. And we have several layers of essentially security, of decentralization and censorship resistance. The first layer is every shard is assigned a committee of validators, right? And you can think of this almost in a way analogous to a shared sequencer set, right? Or a committee of validators from a Cosmos app chain, right? They're running some form of fast BFT consensus, and they're agreeing on what is the block, a block every second. Now, every n number of blocks, that committee is generating a validity proof that the last n number of blocks were executed and built correctly. all shards do this, and all shards send their validity proof to a main shard where they're recursively verified and sent and batched down to Ethereum for the final stage where you get guarantees and settlement of the entire nil network on Ethereum.
Okay, great. So I understand the mechanism of why zk is present, how the sharding works with your validity proofs, and also kind of how this works to unify different rollups. And I think they make a really good point as well. Like, we shouldn't just build more of the same optimistic rollup using EVM and then even just throw like a data availability layer under it, like Celestia or Avail, and call it a general purpose L2. Like, sure, like maybe you can get some very domain specific users on that, or like an enterprise chain or something. But even still, those are like, we should just keep striving to improve the scalability. So I think that we're on the same page there. And kind of coming back to one of the original questions that I had was with regards to the trade-off of decentralization and kind of scalability, kind of coming to a similar point here, which is what kind of extra trust assumptions do I, as a rollup operator for rollup A, as well as rollup B, C, and D, have to accept when using nil for scaling and for interoperability with your zk tech?
Good questions. Okay, so first, like, this isn't a system that's backwards compatible with existing rollups, right? You don't it's not designed to say have an OP stack rollup now just plug in to nil's sharded network. Nil is a general purpose blockchain itself, right? It is, and it's not a compatible solution for, say, an existing rollup to simply plug into this sharded architecture. And this is, frankly, I mean, this is the uphill battle that we have to go against, right? That we are a new general purpose blockchain, and we are not looking to, have this necessarily like hoorah, like everybody is going to just plug into everything. We think that is a really like noble path, and in any way that we can, we want to work in that capacity. But we do fundamentally have this view that you should be building general purpose L2s that scale to a sufficient degree, such that you unlock all of the product experiences that you get on, say, Solana. And I'm an Ethereum, I don't know if I am an Ethereum maximalist. Like, we are, our entire company is an Ethereum maximalist. It's just the culture. But if you look at things like objectively, Solana has done something really interesting in that it's built a completely self-isolated and prosperous ecosystem of applications, because it's effectively offered the product features that application developers want. And sure, there's a trade-off that they made in how they say design their architecture, right? And they've really gone down far the vertical scaling route, and I think that's a very noble cause, and that's actually a route that is going to allow them to unlock unique applications, like potentially on-chain order books, right? You actually need the single machine bottleneck to run those really low latency applications, right? And they've done a great job at that. But we obviously come from a slightly different camp, and we really do see that there needs to be this arbiter of truth that is operationally resilient. Like fundamentally, we want to build a system that is decentralized, autonomous, runs in perpetuity, long after my involvement or anybody else currently at Nil Foundation's involvement in building and contributing to this network. The only way that we can do that and underwrite some of the risk in transferring power, right, in these organizations over decade-long, horizons, is to decentralize and to have base layers that we can rely on, and that's Ethereum. And right now there's really I really don't think there's any way around. I think the Bitcoin L2 stuff is interesting, but again, we have our opinions. Yeah.
Sir, I appreciate the decentralized hurrah. Now, what technical trust assumptions does one assume by
Oh,
using nil is like, so I thought, I was more so of the opinion like, oh, if I'm an existing rollup I could plug in, but you're saying it's more of like a grassroots effort where you guys kind of work together with teams to help them kind of launch within nil. Kind of talk us through this and
okay.
yeah.
Yeah. Totally. So, as I mentioned, there's effectively three layers of like what you can call finality, right? So, the first layer, well, actually to zoom out, to give you kind of like context for how those finalities actually like emerge. Nil is there's a global validator set behind Nil, right? Nil has like a traditional blockchain validator set. That validator set is randomly sampled, right, and assigned to a shard, right? And that shard is essentially like an app chain or like a roll up, like I was saying earlier. And you have this committee of validators that are again randomly selected on an every epoch and build blocks running with some sort of BFT consensus. And we run sync hot stuff, a multi threshold BFT. So, and that's where you get our sort of 1 second, finality, right? Every block, boom, you get some sort of decentralization guarantee that's includes essentially the entire validator set, the selection at that committee level, and then we factor in the random sampling aspect of it, right? Which
And real
is
quick,
one of the
Abby,
real, yeah.
yeah, sorry, is the random sampling similar to like an erasure coding, like a Reed and Solomon kind of type of concept, or it's slightly different?
It's slightly different, but I think it's like a similar spirit. I mean, the point is that you, you randomly select from this global set. So if you were to say just assign, if you just imagine you have 100 validators, if you were just to say, well, these 10 validators, you're always going to be running this shard, you effectively just have like a validator set of 10 for that shard, right? In perpetuity. Now, when you actually start randomly sampling, you pretty much increase your resistance to any sort of 51% attack because it's harder to coordinate between those entities.
Awesome. And so you were putting the pieces together of
Yes.
the broader network.
Yeah. So that's layer one, right? Or layer one of finality, you might call it. Then you have the validity proofs, right? Where every committee, right, at every shard is generating a validity proof for n number of blocks, and those validity proofs they're generated and then they are sent to a main shard where they're verified. Now, over time, we hope that we get real-time validity proofs, right? People are talking about proof generation, and there's a lot of really incredible work being done at the hardware level of this. There's also just the state of the art of proof systems has come a really long way, and we do think we'll get somewhere close to real-time proof generation, but we recognize we are not there yet. So while we live in this world where we have delays, we opt for the BFT consensus, right, as the first layer of defense. Now, as things get faster, we can actually eventually, hopefully, get rid of the consensus altogether because we don't need it, because we can prove things in real time. Now, the validity proof layer, it gets verified on the main shard, right, which is actually run by all validators. So you have the entire global validator set behind that layer. And then the final layer is Ethereum, right, where Ethereum receives one single proof, kind of similar to Polygon's AG layer, and verifies sort of the execution of the entire network.
Sweet. Sounds bullish. I don't have that much time for too many pushbacks. The only one that I'll push back on is, what's the validator count in on like testnet going into live? Is there a maximum validator count? Is there a reasonably decentralized validator count that you guys have in mind?
I can't give you hard numbers for all of them. We're targeting 400, and that's what we've run sort of our internal tests on. That's where we got sort of the 60,000 TPS number. But who knows? We're going to be launching a private testnet in this summer. And from there, we're going to collect really valuable feedback on what are the things that, builders need. I mean, we are building, a decentralized network. We are building a blockchain, but we really do think of it like a product. And we want to be collecting that product feedback. So if folks are interested in learning more, hop in the Discord, hit me up on Telegram, hit me up on Twitter. We're going to be running kind of an exclusive group where people are testing, and we're gathering product feedback and making alterations. But that's all going to happen very soon. Yeah.
Bullish. We had just a couple of minutes. Last question. Is there a point in which adding more validators to a network, it has diminishing returns or doesn't really do much? Like, is it 100, 200? Like, I've heard, in this range, but curious what you think.
Yeah, I mean, this is a good question. We're not going to have enough time to talk about it, but there obviously there are trade-offs, right? The major trade-off with like sharding in general, it's complex. Like it's not like a simple thing to implement. If you want to do it in a decentralized setting, it's even more complex, right? It's complex as just a scaling solution for databases, let alone all the consensus guarantees. There are upper bounds to how many validators you add, but you could just imagine, say, with even out, like, just to give you an intuition, even without putting hard numbers on upper bounds, if you were to say split every contract onto its own shard, right, you may think, well, now I have a really scalable system. The issue is, what if those contracts or addresses want to call between each other? What if they want to send transactions between each other? Exactly. And this is where sort of the task on our end for optimizing the sharded architecture comes into play, because we can't just split everything, because everything will then have an asynchronous call, right? And everything will be communicating with some sort of delay, and also in a different programming paradigm than the synchronous programming paradigm. And so we can have synchronous execution intra-shard, but when things go outside shard, you either have to program in an asynchronous manner, or we have to build some sort of emulator or scheduler like module similar to what Solana has done to try to build that synchronicity. But this is, I mean, I'm not going to sit here and say we have that solved. We don't have that solved, right? And this is why we're really excited to bring in some sharp engineers to come and let's break what we have and see how we make it better.
Brings us all the way back to one of the first points, is about whether it being an interoperability problem with regards to state fragmentation or a scaling problem. And it appears to be a problem unsolved. Avi, thank you for coming on, and best of luck. I appreciate your time.
Thanks, Andy. Really appreciate it.
Cheers.